Let's try to solve this integral. We're going to use this Fourier transform right here. And we've given the function f of x. And we notice here that there's a little bit of a shift. So I'm going to try to rewrite this. And instead, we're going to consider f of x equals e to the negative x squared over 2 sigma squared. So we're going to get rid of the shift. And then later, we'll kind of throw it in afterwards. We kind of have to multiply our answer by e to the I, Q, A. Considering this Q and this A, and then we'll be able to put the shift in later. So let's now go ahead and plug in this f of x into here and see if there's anything that cancels, at least with these constants. So we'll have something like a 1 over, maybe there's a 2 pi. There's supposed to be a squared here, so this should be just a sigma there. And then now we can put in e to the negative x squared 2 sigma squared. We have this integral, though, we have to deal with, so negative infinity to infinity. And then also there's the e to the I, Q, x, and then there's our dx. So all we did was just replace the f of x in here and kind of cancel out these constants. What I'd like to do is actually put this under a single exponent. So we'll just say 1 over 2 pi sigma. Here's our integral. Then we'll have e to the just negative x squared over 2 sigma squared plus IQX, and I'll just put that all under one exponent. Now that we have this form, we're going to try to simplify this a little bit. So we'll go negative infinity to infinity and just call this e to the negative alpha x squared, and then plus beta x. And that way we kind of keep track of our alpha. Alpha is going to be negative, actually positive. It's just 1 over 2 sigma squared, and then beta is just IQ. This is where things start to get a little tricky. So what we're going to try to do is we kind of have to complete the square in here. So we got a negative alpha x squared plus beta divided by alpha x. Okay, we pull out the negative alpha. And then let's just consider that if we had like x squared minus 6x, then we would really want this last part to be a plus 9. And the way we got this 9 is by dividing this thing by 2, so 6 divided by 2, and then we squared it, and that gives us 9. And so we're basically going to have to do the same thing over here, where we're going to take, sorry, this is supposed to be a minus here, but we're going to take this middle part, which is b over alpha, and then we divide this by 2, and then we're going to square it. So that's what we're going to need to add and subtract into this parentheses to be able to complete the square. So kind of negative alpha, here's our x squared minus beta over alpha x. We're going to add this and then also subtract it so that we have 2 copies here. Okay, so this is kind of what we have to do to complete the square here. It looks a little sloppy, but we're just going to take x minus beta over 2 alpha, and that's squared. And then we just have the plus beta squared over 4 alpha squared, and that is how we completed the square. Keep in mind that this is actually all under a single exponent here. And so what we can do is we can pull out this piece over here and get rid of it. So let's go back to our integral. So let's just say we're going to pull this out. We're going to put e to the, there's a negative alpha, but then there's also an alpha here. So we're just going to do negative beta squared divided by the 4 alpha. I'm making tiny mistakes here, so we actually have a negative sign here, because that was supposed to be a plus that we're sort of consuming here. Remember, we needed a plus. So we're going to consume the plus, and we're left with the minus here. Therefore, when we put the minus out here, it's actually supposed to be a plus. Okay, so then we have this stuff over here, and then we still have to integrate negative infinity to infinity, and we have this left over. So e to the negative alpha x minus b over 2 alpha squared dx. let's not forget 1 over 2 pi sigma. But this is what we are right now. This stuff right here looks like negative infinity e to the negative alpha x squared. And this is supposed to be equal to the square root of pi over alpha. The interesting thing is that in this particular integral, there doesn't, a shift doesn't actually do anything. So the answer to this integral is actually the same thing. So therefore we have our answer now, to this at least. And all we need is the stuff in front. So let's go ahead and put 1 over 2 pi sigma e b squared over 4a alpha. Okay, and so now we're in a good shape. We kind of need to replace these back in and then throw this back in because we're shifting it. But essentially, if we do that, then we have a square root of, well, pi divided by alpha. We kind of have this 2 sigma squared pi going on. And then we have 1 over 2 pi sigma e to the, there's a beta squared here. So that's going to be an I squared and a Q squared. And then we have 4, the alpha goes kind of on top with this 2 sigma squared. And then we'll kind of have to throw in this, so e to the IQ a. A is not alpha. A is the shift from earlier. And now everything's going to start to cancel out. This I squared becomes negative 1. The 2 and the forward become a 2. We're now left with sort of this thing. And this is just going to be sort of a sigma on top. There's a sigma on the bottom. So what we get, and the final answer is the square root of 2 pi divided by 2 pi e to the negative q squared sigma squared over 2 e to the IQ a. Unbelievable.